Welcome to this video. In this video, I will introduce how to solve the circuit with the independent current source. Here is an example. In this circuit, there are two independent current sources in total, S1 and this S2. One of them is in one mesh. The S1 belongs to two meshes. How could we solve this circuit? We will use the mesh analysis. There are four meshes in total. Mesh 1, here is I1. Mesh 2, here is I2. Here is I3. Here is I4. There are four meshes in total in this circuit. We could appoint four meshes currents for each mesh, I1, I2, I3, I4. In mesh 1, we could use KVL to list an equation. KVL for mesh 1. There are four elements in total. One voltage source, one R, one R3, R1, R3, and XC, and a capacitor. If we use the KVL, the equation will be, since the I1 and the Vs, they are in different directions. For the Vs, the direction is like this, and for the I1 is like this. So it will be negative Vs and plus for R1 it will be I1 R1, and for R3, since R3 it belongs to mesh 1 and mesh 2, so we could use I1 minus I2 times R3. And then for the capacitor, it belongs to mesh 1 and mesh 3, so it will be I1 minus I3 times XC equal 0. That's the KVL equation for mesh 1. And for mesh 2, since there is an independent current source in the mesh 2, so we could directly to use the current relationship for this mesh. And the mesh current is I2, which is clockwise. For the independent current is IS2, which is counterclockwise. So we could list the equation I2 is equal negative IS2. And for mesh 3 and mesh 4, since there is an independent current source in the middle of these two meshes, we could draw another super mesh. We could draw another super mesh for the two bottom meshes. A super mesh occurs when a current source is contained between two essential meshes. The circuit is first treated as if the current source is not there. We assume this one. We assume it's not there, so which means here is one, just one mesh, and there is just one mesh here. This leads to one equation that incorporates two mesh currents. So for the super mesh, we could list the equation. We can see there are four elements in total in this super mesh, but here we should pay attention to the four elements. For the R2 and the capacitor, we should use I3 mesh current to list the equation. And for the inductor and R4, we need to use the I4 mesh current to list the equation. So the equation for R2 is R2 times I3, and for the capacitor, since it's contained two meshes, mesh 1 and mesh 3, so the voltage should be I3 minus I1 times XC. And for the XL, for the inductor, it's contained two meshes, mesh 2 and mesh 4. So the voltage should be I4 minus I2 times XL, and then plus for the resistor 4, it should be R4 times I4 equal 0. Once this equation is formed, an equation is needed that relates to the two mesh currents with the current sources. So we could move this back. We could move it back. This will an equation where the current source is equal to one of the mesh currents minus the other. So another equation will be I4 minus I3 equal IS1. Since the mesh current I4 has the same directions with the IS1, and the current I3 is another directions of the I3 one. So we need to use I4 minus I3 equal IS1. After we list everything, we could get four equations. 1, 2, 3, 4. And except the I1, I2, I3, I4, all other values they are given. 4 variables, 4 equations. We could solve these combined to solve these 4 equations and get the I1, I2, I3, and I4. In summary, when we solve circuits containing the independent current source, we will check if it belongs to one mesh or two meshes. If it belongs to two meshes, we need to treat it as a super mesh. And if it just belongs to one mesh, we just need to use the mesh current equal the independent current. You just need to remember this principle. I believe you could solve a lot of circuits containing the independent current source. If this video gave you some help, please subscribe my channel. I will record more videos. If you have any question, also leave me a comment. Thanks for your watching.